Now, proceeding from the previous video where we talked about the nuclear reaction, in the nuclear reaction there was the term involved as energy. And now, this energy that we measure in a nuclear reaction, we measure it in terms of Q, and we call it Q value of a nuclear reaction. And what is this Q value? Is basically you have a nucleus and you hit it, or and you have reactants and you have products. That's the line. And the energy absorbed or released during nuclear reaction is known as Q value of a nuclear reaction, and it's equal. It is basically equal to as the difference between the kinetic energy of products and the kinetic energy of reactants. So if we have Kp as kinetic energy of products and Kr as the kinetic energy of reactants, the difference of the two will give us it will give us a Q value. So I can write Q is basically K products minus K reactants. As simple as that. And we can also define this Q value in terms of mass. And the definition will go like this Q value of a reaction. We can define it in terms of mass also. And what is the difference? The difference between the mass of the reactants and the mass of the products, mass of reactants and mass of products gives us the measure of Q value. But what we have to do is that we have mass of reactants minus mass of products. We have to multiply it by C square. So this will give me Q value if I measure it in terms of the masses of the reactants and masses of the products. And if I can measure it in terms of the velocities, I can find the Q value. Now, based on this Q value, we have two types of reactions. We have two types of reactions. Which reactions? Nuclear reactions. Based on energy exchange. The very first is endothermic. Now, endothermic nuclear reaction. Endothermic nuclear reaction. Now, if the mass of the products of a nuclear reaction is greater than that of the mass of the reactants of the nuclear reaction, then this Q value is negative. This Q it's less than zero if mass of the products is if this mass of the product is greater than that of mass of the reactants. And in this case, Q value is negative. Such a nuclear reaction, such kind of nuclear reaction is known as endothermic reaction. And for endothermic reaction to proceed, we have to supply the energy. In this case, we have to supply. So we have to supply the energy from outside in order to have an endothermic reaction. And what is the necessary condition? Q less than zero. And the mass of product should automatically be greater than that of mass of reactants. So the other category of reactions that we have that we can define on the basis of this Q value is exothermic nuclear reaction. Exothermic nuclear reaction. And in this case, it's now obvious. Now, if the mass of the reactants of the nuclear reaction is greater than that of the mass of the products, of the nuclear reaction, then certainly this Q is going to be greater than 0. So Q is going to be positive. Such kind of nuclear reactions are called as exothermic reactions. So during exothermic reaction, what happens? Energy is released. So one thing might be noted here is that exothermic nuclear reaction takes place spontaneously. You are not hitting the target with some external agent. This reaction takes place spontaneously, and you have Q greater than 0. And thus, the radioactive decay is always exothermic. So the radioactivity that we talked about, radioactivity, that's always going to be exothermic in nature, because these reactions take place spontaneously. Now let's take an example for the sake of argument here. The example I had to just play with numbers and to have an idea. Now let's take back that example of nitrogen. We have nitrogen and we hit it with alpha particle, and we have a reaction here. We don't say what we have done, whether we have hit it or something else. What we want here is to find the Q value. If I find the Q value of this reaction is positive, then it has to be a decay kind of situation, spontaneous decay. But if I find that Q value is negative, it's less than 0, then certainly I'll be in a position to confirm that this equation is being executed by an external target. So the various value, we have a reaction here, and we have the mass of the elements that are involved in this. These masses are given in terms of atomic mass units. Now, to go with this, to solve this, what we have to do is, it's very simple. All we need is the mass, the total mass of reactants. So total mass of reactants. Okay, that will be mass of this nitrogen nucleus, okay, plus mass of alpha particle. Okay, so mass is given here. How much is that? That is 14.003 atomic mass units. Atomic mass units plus mass of alpha particle is 4.002 atomic mass units. Okay, so we can add it, and this is 14 plus 4. Okay, so we can add it. What we'll get is we will get 5. We have 0, we have 0.8 and 1 atomic mass unit. Okay, this is the total mass of reactants. Now we would go with total mass of products. So in products, what we have proton and we have oxygen, and we have given the mass of the proton and the mass of this oxygen atom. So how much this is going to be is it will be 16.999 atomic mass units plus 1.008 atomic mass units. So what we are going to have here it will be 17. This is 7. Then we will have 0. Then we will have 0. Then we will have point. Then we will have 8, and 1. Okay, so that will be the case. So that will be the mass of the products. Now what we are interested is we want to calculate Q. So what is Q? Q is mass of it is the subtraction between mass of reactants and mass of products. So mass of reactants minus mass of products into into c squared. But we have already converted that thing in terms of electron volts, and I will simply write here 931 mega electron volts. Now this difference, when we make the difference of, when subtract these two, what we are going to get is, we are going to get minus, and certainly here will be 2, then everything will be 0. So we'll have 0 times 931 mega electron volts, and this will give us nearly minus 1.862 mega electron volts. So negative sign is an indicator of the fact that this reaction will not take place itself. What you have to do is you have to hit this nitrogen nucleus with an alpha particle whose energy has to be 1.862 mega electron volts. So we can conclude from this simple note that this is an endothermic reaction. And if we find a reaction, if we use the same calculation for those reactions that are taking spontaneously, or in all of these cases, the Q value that we will have, it will be positive for all of those nuclear reactions.